Why is basic computer knowledge important, and how do you deeply understand technology in a changing world? In expanded detail, summary of what will be covered. This deeper explanation continues the structure of the previous response, now adding significantly more detail to each theme. It begins with why basic computer knowledge is essential, then explores the deeper layers of understanding from user-level literacy to systems-level expertise. It addresses the tools, thinking patterns, learning progression, and the importance of staying in tune with trends such as AI, cloud, and cybersecurity. Finally, it highlights the societal and personal empowerment that results from this understanding. The foundation of computer literacy. At its core, basic computer literacy includes knowing how to operate a device, whether a laptop, desktop, or smartphone, confidently and responsibly. It includes understanding user interfaces, knowing how to use a graphical interface, like Windows, macOS, or Linux, manage Windows, launch applications, and organize files and folders. File system navigation, recognizing different file types, .docx, .jpg, .exe, understanding directory structures, copying/moving files, and installing/uninstalling software. Keyboard shortcuts and input methods, being efficient in navigating with hotkeys, understanding touch gestures, and utilizing search functions effectively. System settings and customization, managing device settings for display, sound, accessibility, and input devices, connecting to Wi-Fi, updating software, and managing storage space. Digital etiquette and productivity, using calendars, reminders, and task management software, understanding email structure and professionalism in digital communication. Basic literacy is about being in control rather than confused. It eliminates friction in daily life and is the first step in interacting with the deeper layers of technology. Digital communication and collaboration. Modern work and learning are defined by the ability to communicate and collaborate across distances. That requires digital fluency in several environments. Email systems, understanding CC, BCC, reply all, spam filters, and email signatures. Cloud platforms, using services like Google Drive, Dropbox, or Microsoft OneDrive to store, share, and collaborate on documents. Real-time collaboration tools, mastery of platforms like Zoom, Microsoft Teams, Slack, and Google Meet, including screen sharing, file transfer, and collaborative editing. Project management platforms, familiarity with tools like Trello, Asana, Notion, or Jira for team coordination and workflow design. Online presence, managing digital identity across platforms like LinkedIn, GitHub, forums, or academic profiles. These tools are digital extensions of physical communication and organization. Mastery of them enables remote work, freelancing, networking, and accessing global communities of knowledge and support. Security and self-reliant security awareness is part of digital maturity. Most individuals are unaware of the breadth and depth of threats they face daily. Key aspects include authentication, understanding how passwords, two-factor authentication, 2FA, biometrics, and password managers protect access. Phishing and social engineering, recognizing fake emails, malicious links, and impersonation attempts, staying skeptical of unexpected requests. Software updates and patching, knowing why updates are essential for fixing vulnerabilities and not just for feature upgrades. Backup and data recovery, using local and cloud backups, understanding redundancy, and planning for hardware failure or ransomware attacks. Privacy control, managing permissions for apps, browsers, and social media, using VPNs and privacy-enhancing tools like browser extensions or encrypted messengers. This knowledge empowers users to take care of their own digital safety, reducing dependence on IT support and minimizing damage from inevitable risks. From usage to understanding once confident in day-to-day use, the next step is pulling back the curtain. Operating systems, learning what an OS actually does, managing memory, scheduling processes, handling I/O input/output, and providing a user interface. Hardware fundamentals, understanding the function of CPU, RAM, storage, GPU, and how they relate in terms of performance and cost. File systems and boot processes, knowing how data is stored and retrieved, what happens when a computer starts, and how drivers link hardware with software. Command line interfaces, gaining basic fluency in Bash or PowerShell enables deeper control, automation, and system diagnostics. Networking basics, IP addresses, MAC addresses, ports, protocols, HTTP, HTTPS, FTP, DNS, and routers/switches form the vocabulary of how machines connect. Software development lifecycle. Understanding how an idea becomes an application through planning, coding, compiling, testing, deployment, and updates. At this level, you are not just using a device, you're beginning to understand it as a system of interrelated parts, governed by logic, architecture, and protocol. Logical thinking and computational mindsets. This involves internalizing how computers think and applying that to your own reasoning. Algorithms and flow control. Understanding basic algorithm types, sorting, searching, traversing, and control structures. If-else, loops, recursion. Programming fundamentals. Writing simple scripts or programs in Python or JavaScript builds mental models for variables, functions, data types, and objects. Debugging skills. Learning to track and resolve errors teaches persistence and methodical analysis. Data structures. Arrays, lists, stacks, queues, trees, and dictionaries. Essential building blocks for solving real problems in code. Version control systems. Using Git and platforms like GitHub fosters collaborative development and structured change tracking. This way of thinking enhances problem solving beyond technology. It equips you to break down real-world problems into sequences, models, and conditional logic. Where to begin and what to build upon learning should be layered and iterative. Stage 1. Focus on usage fluency, navigating interfaces, using productivity tools, managing files and settings. Stage 2. Learn concepts behind the systems, what operating systems manage, how data is stored, how computers talk to each other. Stage 3. Begin writing code. Python is friendly and powerful for beginners. Build small utilities, automate tasks, or analyze data. Stage 4. Understand web technologies, HTML, CSS, JavaScript. How websites are built and hosted. What happens when you load a page. Stage 5. Explore system-level understanding computer architecture, memory management, and how operating systems enforce security and access control. Stage 6. Choose a domain: data science, cybersecurity, cloud computing, mobile development, AI, and dive deep. Learning should be project-driven. Build something real. A simple website, a budget tracker, a chatbot, or a home automation script gives you purpose and motivation. Concentrating on the right trends to stay relevant, you should understand not just how technology works, but where it's going. Artificial intelligence includes machine learning, large language models, computer vision, and reinforcement learning. Learn the math, but also the ethics and applications. Cloud computing, platforms like AWS, Azure, and Google Cloud power modern infrastructure. Learn about virtualization, containers, Docker, and orchestration, Kubernetes. Cybersecurity, the arms race between attackers and defenders is ever-evolving. Concepts like zero trust, penetration testing, threat modeling, and cryptography are critical. Blockchain and decentralized systems. Beyond cryptocurrencies, look at decentralized identity, smart contracts, and tokenized governance models. Quantum computing. Still in early stages, but reshaping what's possible in computation. Learn the principles even if you don't use them daily. Extended reality, AR/VR. Explore the development of immersive applications for training, education, entertainment, and simulation. Edge computing and IoT. Understanding how billions of devices operate on the edge of the network with local processing and minimal latency is vital for embedded systems and real-time applications. Trends are not just topics, they are ecosystems. Learn the tools, languages, cloud services, and communities that are shaping these areas. The importance of lifelong learning. This is not a race with a finish line. The moment you stop learning, your understanding begins to age. Strategies for sustained learning include: follow documentation. Learn to read and understand docs instead of relying on tutorials alone. Join communities. Reddit forums, Discord servers, GitHub projects, and Stack Overflow are vital learning spaces. Attend workshops and boot camps. Immersive learning speeds up mastery. Build and break. Nothing teaches faster than making mistakes, breaking systems, and fixing them. Teach others. Explaining what you've learned reinforces your knowledge and sharpens clarity. The goal is not mastery of all tools, but the confidence and ability to approach any new tool with competence. Empowerment through understanding. When you understand technology deeply, you stop being a passive consumer and become an active creator. You can question decisions about surveillance, bias, privacy, and automation that affect your life. You can build tools to solve your own problems and amplify your impact. You gain economic opportunities in high-growth fields, regardless of geography. You develop a mindset that embraces change, handles complexity, and resists manipulation. This is not just about careers in tech. It is about being an aware and empowered person in a digitally mediated world. Final thought. To deeply understand technology, you must be both humble and curious. Start from what you know, stay uncomfortable, and build layer by layer. Basic computer knowledge is not a small skill. It is the key to entering and shaping the future.
If you're enjoying the content, go ahead and hit that subscribe button, drop a like, and leave a comment. I would really appreciate it. I love hearing what you think, Hank, and your support helps the channel grow big time. Thanks for being here. It means a lot. Let's get